Okay, here we are. Mr. Eisner here, looking at the alternating series error. I'm going to try to offer up some kind of an explanation here. So what we have is we have this alternating series, and we know it's alternating because of this -1 term raised to the k plus 1. Now, all that means is that when k is 1, the power is 2, and so it starts with a positive term. That's all. If this was a k instead, that just means the first term would have been negative instead. But it's alternating, and there we go. The a sub k's are all positive. It's this piece that causes them to alternate sign. We also know, for this example, that the limit as k approaches infinity of a sub k is 0. So if you looked at the terms themselves, they are shrinking to 0. We also know that each next term, k plus 1th term, is less than or equal to the previous term. These are the two conditions that cause an alternating series to converge. So I just know that we're working with a convergent series here. Okay, so how do we figure out what this error actually is? I'm going to do it visually. I'm going to try. So I'm going to start with a number line. And if all we look at is the very first term, here it is, a sub 1, here's what we know about that. That's also s sub 1 because it's the first term, so it's the first partial sum, and that's fine. Now, if we add in the next term, which is a negative term, it's going to take us from a1, and it's going to move us backward by subtracting a sub 2, moves us to a new point on the number line, and that point is actually now s sub 2. We can keep going, and if I add in the next term, I'll be a positive a sub 3, but be careful, it can't go past a sub 1. Why not? Because of this little guy up here. Because each term is less than the previous term, so when it adds back, it can only go out as far as a sub 1. So let's see if I can erase a piece of that. There we go. So if it's going to come out, it's going to come out somewhere less. Let's just say less. There's my plus a sub 3. That puts us at a new location, which is the third partial sum, which would be here. Now, if you kind of see what's happening, we can do this again. From s sub 3, I would subtract a sub 4. It can't go as far as it did the last time. Again, each term is getting less and less. So that puts us now at new number line. And we're here now. This would be s sub 4. And so if we kind of look at this, and I'm going to do them all on this number line here, we're going to add back an a sub 5, then subtract an a sub 6, and add back an a sub 7, and so on. And what we find out is that we're heading somewhere, and somewhere in the middle here is going to be where that infinite sum is headed. And it just keeps bouncing back and forth around that sum. It goes positive above it, then below it, then above it, then below it. But every time getting closer and closer and closer. So the question is, after each one of these additions or subtractions, how far might we have been from that true sum wherever it happens to be? And what we find is that when we're at, say, s sub 2, after adding 2 of the terms, here's how far we actually are from the real sum, the infinite sum. Notice that that amount is less than or equal, because we're never sure, these could just pass it, less than or equal to the next term a sub 3. Let's look at s sub 3. How close is it to the true sum? Well, it's less than or equal to the a sub 4, and so on and so on. So what we find out is that the error for adding up, say, k equals 1 to n of our k plus 1 a sub k, the error for this is less than or equal to the absolute value, although we don't need that because it's just the A terms themselves are positive. So the error is less than or equal to the next term. If we're at the nth term at this point, it's going to be less than or equal to A sub n plus 1. Because again, like we saw, second partial sum is how far away? Less than or equal to the third term. Third partial sum, less than or equal to the fourth term. So the nth partial sum, less than or equal to error, the n plus 1th term. Hopefully that explains it. I will be back with answers to the questions at some point, maybe tomorrow. And look for something. I'll probably give you one assignment over the, quote, spring break to look at for the very second to last topic. We'll look at that coming up soon. Thanks, everybody.